Hi, everyone. We are excited to be at ElasticON this year. I'm Amrit Chandrasekhar, Director of Observability at Reliability Engineering and Machine Learning Operations. Together, I have Shaktivel A, Kirti Rajan, both are principal architects working on observability team at Informatica. Informatica is an enterprise cloud data management leader. We enable customers to transform the most critical assets and realize business values using IDMC, Informatica Intelligence Data Management Cloud, which is powered by AI, which is an end-to-end management platform that connects, manages, and unifies data across multiple clouds. More than 85 of Fortune 100 clients rely on Informatica, and it's across more than 100 countries. To learn more about Informatica business and customer success, please check the links here. In today's topic, we're going to talk about how Elastic powers Informatica's observability, SIEM, and MLOps. We've been in this journey with Elastic for the last 3 years. We've been through various phases. We started to start with a very small amount of data to migrate from one of the tools into Elastic on logs and metrics. We started at a very small scale, and now we are at 37 TB of data that we ingest per day. A large amount of data comes from product logs, metrics, application performance monitoring, SIEM, which is our security logs, and we collect a lot of other application insights, and we store everything at Elastic. We collect 2.8 trillion documents a month. So when we search for a period of 90 days, there's a lot of data that gets retrieved. And all these are very powerful metrics. And now we are forming data lakes and started to use this data to get much more valuable insights about how our products are performing at cloud. We use Kafka to ingest a lot of this data, especially from application logs. And it's a large Kafka cluster. We use public MSK, which is the managed service Kafka from AWS. Using Elastic Stack, we are collecting data across 4 different cloud providers, 20 plus regions, hundreds of applications deployed across 300 plus Kubernetes clusters and 8,000 virtual machines. We collect logs, metrics, traces into Elasticsearch, Kibana, and visualize using Kibana. This is a lifecycle of logs. Like there are raw logs, we harvest and dissect logs in beats. There's some real-time processing using Kafka. We consume and transform some logs in logstash. All the data is indexed and stored in Elasticsearch and visualized through Kibana. So we just thought this is one of the cool slides to show about like how the logs have been created and in the end visualized in Kibana. SIEM is one of our largest clusters. We have like about 8.5 billion events per day that we collect logs, and there are like 400 plus detection alerts that get created out of the pre-built detection rules, and also we write custom detection rules. We have a dedicated security team that uses this SIEM cluster to use a lot of SIEM features, like log collection, analysis, correlation, forensics, transformations, and we apply machine learning on top of these logs as well, which helps us in real-time alerting, user activity monitoring, dashboards, reporting, and auditing. For the next set of slides, I hand over to Kirti from my team. Over to you, Kirti.
Thanks, Amrit. Hello, everyone. So by using Elasticsearch, we are able to get a lot of business values. We are getting improved search and discovery. So basically, Elasticsearch enables us to retrieve large amount of data and with very accurate results. And the search is particularly it's pretty fast. We're able to get real-time insights for our incidents. So in case of any incidents, we are able to get logs, metrics, and traces everything at one place, which is actually reducing the mean time for our incidents. It acts as a single pane of glass where we are using Elasticsearch as a single tool to gain insights of all our products. They are posted in different regions, different clouds. Also, we with Elasticsearch we have done a lot of optimizations, and with that we are able to save a lot of cost compared to our previous solutions that we have used. Improved security. So we have always followed security first approach for all our products, and we are leveraging all the Elasticsearch SIEM features and other features to improve our security, as well as along with getting the logs into the tool. So as Amrit said, we are monitoring all the most of the applications of Informatica, and there is a huge amount of logs. There is a lot of services that we monitor. So all these services we monitor based on this principle. We call it as reads. So it's number of requests coming to the service, or the number of errors, availability of the service, duration of each of the transaction, if there is any latency, or if any particular service is taking more time, saturation, how full is the services, basically if the backend infrastructure is responding well or not. So we measure all our services based on these KPIs. Some of the problem statement that we are able to resolve using Elasticsearch. We have unified SIEM tool where we are collecting all the security logs from different cloud providers. We are using CloudTrail logs, which again to identify if there is any unintended activities going on in our application. We are using Elasticsearch to get the network traffic that is coming to our applications. Also, we have configured the alerts, and basically based on the log errors and response codes, we send alerts so that different teams can be able to see how the application is performing. With Elasticsearch APM solutions, we are able to measure the performance of each application, and we are also basically monitoring all the logs of all our SaaS tools, like K8s, control plane logs, and all. Next. So these are the few observability dashboards. Basically, we have built on top of the Elasticsearch default dashboards. This actually helps us in keeping a tab on all our services, as well as all the metrics, like how many services we have, and what is the mean time of mean response time of each service, or how many number of APIs are hitting all the services. Same way, we also have different Elasticsearch clusters. We have different Elasticsearch clusters for different environments. And also we have a monitoring cluster which monitors all our Elasticsearch clusters. We have some customized dashboards where we measure how many what is the amount of logs each of the business unit or business entity they are sending it to our Elasticsearch, and similarly how many users, and all those details we captured through Elasticsearch. Yeah, I'll hand over to Sakti now. He will take over our ML journey as well as the architecture of Elasticsearch.
Yeah, thank you, Kirti. Hi, everyone. So in continuation with Amrit and Kirti, we have enabled our logging. We started our journey to index our logs, and we started using a ML feature from Elasticsearch this is one such example of out-of-the-box dashboard that we get. So this dashboard gives us a forecasting model of Elastic, which offers us just by choosing or picking few critical fields like service name, and it is going to forecast us like how well our application is performing, and it's going to detect an anomaly if there is any unexpected spikes or something like that. And the next important feature that Elastic enabled us is on measuring the performance of our application. So we work mostly on microservices. So APM is one of the Elastic solution which helped us to navigate through applications and measure the application performance. In case of incident, this solution helps us to identify the bottlenecks of a particular microservice and enables a debugger to um, find the root cause of the issue pretty quick. And it also gives you a service map that is shown in the slide here, which gives us a pictorial representation of how the microservices interact within other services. And having talked about the ML, so we initially started our journey with Elasticsearch to collect the logs, and which enabled us to even apply the machine learning models on top of the collected logs. So the first use case what we identified was how much data we are expecting over a period of time, and what is it expected in the upcoming days as well. So ML model helps us, Elastic ML helps us to identify how the logs are getting ingested by learning over a period of time. And if there is any unexpected spike in the logs or metrics, or if there is any low logs, it will proactively alert us, and our operation team will be able to catch the issues even if something is happening unexpectedly. And on the same lines, like we have network logs, which has been indexed into Elasticsearch. So out of the box, we were able to configure a few anomaly detection on our networking traffic. So this networking traffic would be basically on the load balancer logs. Um, this machine learning model will help us to identify if there is any unexpected spike in our network traffic, and it will proactively give us an alert to a respective team, and they could easily figure out what's happening on our production network. So which helped us in enabling our observability on a kind of a 360-degree view on how things are happening on the application infrastructure. And same holds good for DB connections as well. So there are a lot of DB issues which were identified by our Elastic ML. So DB failures predominantly happens when there is a unexpected spike of DB connections which were left open. So this model was able to identify like how Elasticsearch, how the DB connections, DB connection count is increasing over a period of time by learning the pattern from the previous trends or something. So, and same way it holds good for thread hunting as well. And there are a lot of predefined or pre-configured models which comes out of the box, which helps us in most of our observability stack. And this is to just to give an overview on how our architecture has been placed in Informatica. So we have multiple sources of logs, which Amrit spoke about, multi-cloud providers as well. So we have differentiated this into three main categories with respect to this architecture. Like one is on the application logs, which will be basically microservice logs, and it can be a microservice traces also. And there are a few logs from the cloud provider managed services like CloudWatch logs or control plane logs of AKS cluster, things like that. And every cloud provider have their own standard of security logs as well. So we had a challenge to bring all these logs into Elasticsearch. So we have an intermediate layer for each of the solution. So for getting all the application logs, we make use of managed service called Kafka, which is exposed um, publicly so that it can be accessed anywhere. And we index the logs to Elasticsearch through logstash. And at the same token, like we have a lot of platform logs from the cloud providers. So we use solutions like Amazon Kinesis, which helps us to stream the logs, and logstash pulls the logs from Kinesis and index to Elasticsearch. And based on the security logs from different cloud providers, so we have a different mechanism for collecting those security logs and storing everything in a single unified place where on the Elasticsearch. And we have very good backup and restore mechanism to handle our disaster in case of disaster. And next comes the Kibana, which helps us to make use of all this collected logs and traces. So which enables us in most of the use cases, such as searching, enables the SIEM capabilities. It enables the ML capabilities, identify the issues, root cause analysis, anomaly detection, and it can trigger alert based on the alert notification that we configure. Next slide, please. During this architecture, we have come across multiple challenges. We picked a few of the top 5 challenges that we have addressed in order to support the scale of logs that we are supporting today at Informatica. One big challenge was on the log size. So as Amrit specified in the initial slide, like we handle like 35 TB of log per day. So while we were handling so much of logs, the indexing logs to Elasticsearch was a big challenge because of the back pressure. Elastic cannot handle so much of requests. So that's where we introduce an intermediate layer of Kafka. So which stores all the logs, and the logstash will have an option to collect the logs from Kafka and index to Elasticsearch without impacting the performance of the Elasticsearch, because Elasticsearch operates at 2 levels. It enables you to write the logs, and it enables the user to read the logs at the same time. So this made a very good very good solution for making Elastic very operational as well. And with respect to the file beat, there are a lot of issues which were reported by multiple product teams. Like when you see the logs were getting dropped just because before even the file beat reading the logs on a microservices in case of Kubernetes architecture, the logs get rotated, so the logs get dropped. We don't see the 100% logs coming to Elasticsearch. So we worked hard to find few of the performance tuning of file beat configuration, which enabled us to ship 100% logs without any issues to Elasticsearch. And Elasticsearch was not only used for observability, and it even integrated with the products as well. The products directly talk to Elasticsearch to get few of the traces and project the dashboards in our applications as well. So to enable that, we try to route through an API gateway, which enables us to control the number of requests that it can come to Elasticsearch to avoid a kind of a DDoS attack, which can initiate and bring down the performance of the cluster. So we are trying to manage that through API gateway. And few performance issue with runtime fields were addressed by migrating this runtime fields into fields in the beats itself. And storage cost was predominantly a bigger issue for us since we are handling a huge amount of data. We implemented a feature of synthetic source, which drastically reduced like 20 to 30% of our storage cost, and which enabled us to efficiently store more logs as well. Yeah. And I'll let Amrit to speak about the next slides.
Yeah, thank you, Shakti and Kirti. There's a lot of issues and challenges that we faced, and Elastic has been an amazing partner to work with them to remediate a lot of these issues and learn a lot of new things. So we're just getting started, and this year we would hope to complete some of these features that are listed here on AIOps, incident management, RCA, open telemetry, eBPF, continuous profiling, enterprise search, and Elastic Agent and fleet management, which is like a centralized management of beats. There's a lot of work to do this year, and we're looking forward for using Elastic a lot more than what we are using today. Looking forward for it. And thank you everyone for listening to the session. Looking forward for connecting with everyone. Thank you.
Thank you all.
Thank you all.